This video is part 1 of the 9.1 notes. So we are going to get through example 1 and the practice problem, and then you'll be able to start the 9.1 packet. That's an assignment on Google Classroom. So it says, suppose we want to estimate the proportion of adult Americans who believe the amount they pay in federal income taxes is too high. Since we cannot survey every adult American, we can use a sample of adult Americans to arrive at an estimate, and then we can determine a level of confidence and a confidence interval. So before I get too far into this, I would recommend that you either print off the blank note packet that I provided or take notes in some way, so then that way you can reference your notes as opposed to having to go back and watch this video and find where it is that I talked about what you're looking for. So I encourage you to take notes in some way. And so here's something that kind of is a blanket statement regarding chapter 9. In chapter 8, which is what we just did, we were given information about a population and we used it to find information about a sample. And so in chapter 9, we're essentially working in the opposite direction. We're going to take information that we're given about a sample and use it to find information about the population. And so that's what they're talking about here. If I want to know the proportion of adult Americans who think they pay too much in income taxes, I can't survey every adult. They don't want me going out in public right now. And so instead, I survey 1,020 adult Americans, and I look for information regarding that sample. So of those 1,020, 490 say yes. They believe that their taxes are too high. So it says use the sample data to find a point estimate, which is the value of a statistic that estimates the value of a parameter. Just remember, statistic goes with sample and parameter goes with population. So the point estimate just means what is this sample's, the sample proportion. So what is 490 over 1020? Well, I use my calculator. I take 490 divided by 1020, and I get that the sample proportion suggests that 0.4804, that proportion of people say yes. So based on this point estimate, we determine that 48% of adult Americans believe they pay too much in federal income taxes. That's the sample proportion. Is it the population proportion exactly? If we surveyed another 1,020 people, would we likely get that exactly 490 say yes? Probably not. Doesn't necessarily make sense that it's going to be exactly the same, but it should be close. Unless either one of the samples that we're working with is skewed in some way, but it should be close, relatively. So to offset the fact that different samples predict different population proportions, we use our point estimate to create a confidence interval. So the confidence interval means that I'm not going to get this exact number as the population proportion. I'm going to get a point estimate, and I'm going to add or subtract a margin of error. The margin of error is how far spread out the confidence interval is in one direction. We can calculate the margin of error by hand. Your book goes into that a lot, so feel free to look at that if you're bored this week. It might be provided to us, or we'll use our calculator, and I'll show you those buttons in a second. But right beneath it, it says we want to be in a 95% confidence interval. So the level of confidence is going to vary depending on the problem. So I don't know that 48% is the population proportion, but I want an interval that's going to include that population proportion, and it makes sense that it should be close to 48 unless I just so happen to get a sample that's very skewed. And so I'm going to use my calculator, and I'm first going to click on Stat, and I'm going to scroll over to Tests. And I want one prop z int, which is one proportion z interval. And so notice that I'm going to bypass one proportion z test, and I'm going to go down to one proportion z interval. I need the interval, not the test. And so I'm going to click on interval, and I have this x and this n. Now in my original problem, the x is just the number of successes or that agree to whatever it is you're talking about, and then your sample size is your n. So for me, x is 490, and N is 1020, my point estimate data. And then I want my confidence level to be 95%. So I like C level of 0.95. And then I'm going to hit enter, and I'm going to calculate the confidence interval. So we can say we are 95% confident that the proportion of Americans who believe their federal income taxes is too high is between, well, 0.449 would be 45, and then 0.511 is 51%. So I am 95% confident that the population proportion is between 45 and 51%. So it says, I want to know how many people at SHG are left-handed. This is a great question for us to be doing on a e-learning day. So if we survey, let's say there's 24 students in our class, which would be if everyone was here. I don't know how many of you are left-handed. Maybe you can comment on this video if you're left-handed and we can find better stats. But let's say 5 of you are left-handed. I don't know if that's true or not. It might be more, it might be less, but that's what we'll use. We're going to use our calculator to find the confidence interval. And so proportions must be between 0 and 1. Oops. So I'm going to go to stat. I'm going to go over to test. I'm going to go down to 1 prop z interval and hit enter. And this time I want X to be 5 because I have 5 left-handed people in my class of 24. And let's see, I want to be 95% confident. So I calculate and I analyze. So I've got 0.045. So I would round that up to be 5. And then 0.370, which is 37. So I want to know the proportion of people at SHG that are left-handed. And so I say that I'm 95% confident that the proportion of students at SHG that are left-handed is between 5 and 37%. So that's part 1 of this video. Part 2, we'll move on to the next examples.